So for today, we are going to continue on with our discussion of lines. I know we've been going back and forth between lines and angles. Today actually incorporates both. We're going to look at a very special type of line called a transversal, which interacts with other lines, therein creating angles. And those angles have special names, and in special situations, they have special relationships. A lot of special stuff today. So we're going to start with some of the basic, get some of the vocabulary in there, get a little bit of practice identifying what we're talking about, and then we're going to apply it to some unique situations which allow us to calculate a lot of different things relatively quickly. So first thing we have here, a transversal is a line that intersects two or more lines. So here in this diagram, we have lines L and M, and they are being intersected. Both of them are intersected by the same line, T. So an example here would be line T. Remember, you can name a line either by 2 points or by a lowercase script letter. Now, technically, if you were to extend these lines out further, you could argue that some of them are transversals for the others, but in this situation, based off of the small little window we're peeking at here, line T is a transversal of lines L and M. Now, try to fit this on the screen here. And again, you have copies in front of you, hopefully. Those of you online, if you need me to zoom in at any point, just let me know. But here in this diagram, we're going to pick out some really unique relationships or pairs of angles, I should say, that are formed when two or more lines are intersected by a transversal. So every time you have two lines intersect, you create 4 angles. We've talked about some of those already. We talked about linear pairs, which are adjacent and supplementary. We've talked about vertical angles, which are always congruent. We've talked about some of those relationships, but now we're throwing in another line, so we're ultimately going to have 8 angles to keep track of until we even increase the complexity from there. So the first one, I'll zoom in a little bit. The first one we have, if we take a quick look at this diagram here, again, we have lines L and M being intersected by transversal T. Here at the top, where T and L intersect, we have 4 angles labeled 1 through 4. Where T and M intersect down here at the bottom, we have 4 more angles labeled 5 through 8. Now, one of the first types of angle pairs that are created from this interaction is what are called corresponding angles, which more or less are just angles that are on the same side of the transversal and in the same position. I'm actually highlight 2 of those parts there. Same side of transversal, same position. If you want to, what it means by same position is opening in the same general direction. So if I zoom out here just a little bit, there are multiple examples of corresponding angles in the diagram we were given. So if I'm looking at the same side of this transversal, I'm just going to work on the left-hand side first, going in the same direction. I'm going to start with angle 1. It's on the left-hand side, opening kind of up and to the left. What other angle would be corresponding to that one? 5. So angle 1 and angle 5. Well, then what about angle 4? What would be corresponding with angle 4? 8. So angle 4 and angle 8. That takes care of the left-hand side of my transversal. Jump over to the right-hand side. What would correspond with 2?
6.
2 and 6. And then with 3?
7.
3 and 7. That's it. Those are in that particular diagram, those are the only 4 different sets of corresponding angles. So 1 and 5, 4 and 8, 2 and 6, 3 and 7. Next one, alternate interior angles. Now, a lot of the clues are actually in the name itself for this one. First off, they are interior, meaning between the two lines that were intersected by the transversal. So in between, they're kind of sandwiched between, in this case, lines L and M. They are also non-adjacent, meaning not side by side. So they don't share necessarily the same vertex or a ray. And third, they are on opposite sides of the transversal. So one is on, say, the left and the other one is on the right. So when it's talking about interior angles, right now, the only interior angles we have in this diagram are angles 3 and 4, 5 and 6. So that takes care of the interior part. The alternate, here's where some of the confusion comes in. The alternate means opposite side of the transversal. But I wouldn't say 3 and 4, even though one's on the left, one's on the right, because they also cannot be adjacent. Angles 3 and 4 are adjacent. So if 3 and 4 can't be paired, what's going to be paired with 3?
6.
Careful. 3 and 6 are on the same side of the transversal, so they're not alternate. 3 and 5. And then what would pair with 4? Six. So angles 4 and 6. Good news is these definitions you now have. So anytime I were to test you on these, if you're like, oh, I don't remember what these are called, you can come back to this section. So alternate means they have to be on opposite sides of the transversal. Interior means it's between the other two lines, just so long as they're not adjacent. Third one, kind of similar, using some of the same vocabulary. This time focused on exterior angles. So all the other angles we weren't just considering. So 1, 2, 8, and 7. Again, they are non-adjacent, meaning not sharing the same vertex, not attached to each other. And because they are alternate again, they are still on opposite sides of the transversal. So as I mentioned here, 1 and 2 are considered exterior, but they're adjacent, so we wouldn't want to pair those together. 8 and 7, same situation, also exterior.
1 and 7.
So you're saying 1 and 7, okay, and then that would leave 2 and 8. So angles 1 and angle 7 are alternate exterior, and so are angles 2 and 8. Last one here in our angle pairs are consecutive interior angles. There's that word again, interior. So we're back between our other two lines. They are, again, interior angles, but they are this time on the same side of the transversal.
3 and 6.
3 and 6 and 4 and 5. Good. So we have 4 different names we can use. Technically, we have some other ones that we could toss in from previous, like linear pairs or vertical angles from last week. But we have lots of names now we can use to identify and describe pairs of angles. Usually it's more helpful when you're trying to talk to somebody about it. Sometimes we don't always have a diagram, or if we don't have a diagram verbally explaining it, you could then kind of sketch up a diagram. It's why the vocabulary behind it is so crucial. All right, so we're going to do some practice here, starting with the first example. So we have A through F goes with diagram 1. Again, just for those who are online, make sure you guys can see it as well. We have what looks like lines P and Q being intersected by transversal R, which has resulted in 8 different angles. We're going to go through, we're being given specific angle pairs. We want to name those angle pairs using one of the options from up above. So first one we have here, zoom out a little bit. I think I can fit it in from there. Angles 1, so all the way over here on the left, and 8. Alternate exterior. They're on opposite sides of the transversal, and they are outside the 2 lines that are being intersected. So I'm going to say alternate. I'm going to abbreviate exterior. Are you guys okay with that abbreviation? Alternate exterior. Otherwise, it's going to take forever. What about angles 2 and 3? Consecutive interior. Yep, consecutive means on the same side of the transversal. Interior means they're inside or between the other 2 lines. So consecutive. I'm going to write that word out just because it feels weird to abbreviate it. Consecutive interior. What about 5 and 7? They're on the same side of the transversal. They are corresponding. They're opening in the same general direction down and to the left. So these would be corresponding. Two and 7. Alternate and interior, I'd agree. One and 3. Corresponding. They're on the same side, opening in the same general direction. What about 6 and 7? Consecutive interior. Same side of the transversal, both interior angles. So consecutive interior. So there are our first classifications given our first diagram. That one, pretty straightforward. We just had a pair of lines intersected by one transversal. Obviously, we can't just keep it that simple forever, which is where the second diagram comes in, spices things up just a little bit. I'll give you guys there just a couple more seconds if you're still jotting it down. So I'm going to zoom in on this diagram here before we dive into it. First off, a lot going on. This time it's a little bit different because we don't have just 3 lines, 2 with a transversal going through it. We have 4 lines. So we actually have multiple relationships going on here in terms of what we could classify as a transversal. So for instance, with respect to, say, lines C and D, how many transversals do those 2 lines have? 2. So A is a transversal of C and D, which gives us these 8 angles to consider. But B is also a transversal of C and D, which gives us another different 8 sets of angles. Now, we could alternatively think of it as if A and B were our lines, that would mean C and D were transversals. But what we've done is we've doubled the amount of angles to keep track of. But if you look down below here, very, very important, when we are describing angle relationships or angle pairs in this case, it's very important that we can definitively say they belong to the same transversal. in order for us to describe it as being one of these angle pairs. What that means is if I use angles 1 through 4 here, for example, what grouping of angles has nothing to do with 1 through 4? Careful, 5 through 8 we could argue that C is the transversal there. 13 through 16. This set of angles has to do with lines B and D, whereas the first 4 have to do with A and C. There's nothing tying them together, which means there is no relationship between these 8 angles, and then vice versa. 5 through 8 and 9 through 12 have no relationship whatsoever in this case as well. So there are some thrown in here to distract. So make sure you can say, yep, I know which transversal this is tied to, because technically all of these lines could be considered a transversal of another 2. So digging in here, you should have the diagram there in front of you. Angles 5 and 13.
Consecutive.
Careful, consecutive would be on this, you're close. They are on the same side of the transversal, but consecutive is tied with the word interior. And one of these is not an interior. So now we got the flip side. One of them is an exterior, but they're not alternate because they are both technically, if you think about it, if we use line B as our transversal, they are on the same side of transversal B, opening up in the same general direction.
Corresponding.
They would be corresponding. About 7 and 14. Looks like B is our transversal there as well. Alternate, that's good. Ah, close. Alternate interior, because if you're imagining B is the transversal, the 2 lines in question then that they're intersecting is C and D. So 7 and 14 are between C and D. If it helps, if you have a scrap sheet of paper, cover up these other 8 just to kind of avoid that distraction. So like imagine, I don't know if I can do it there real quick. You know, imagine you're looking at it from this perspective. That extra stuff can be really distracting. All right, so 7 and 14 are alternate interior in this case. About 3 and 6. Changing perspective here, C is now the transversal of lines A and B.
Alternate exterior.
You said alternate exterior? Yep. Nine and 16. Okay, so now a new change. D is our transversal intersecting the lines A and B. Alternate exterior. Okay. What about 4 and 7? So back to transversal C.
Alternate interior.
Careful. They are both interior, but they're not alternate. They are consecutive. Two and 10, transversal A this time. They're both on the same side, so anything with the word alternate we can throw out. So consecutive interior would work, except 2 is an exterior. So that must leave then corresponding. Well, 8 and 14. Now we're to transversal B. Consecutive interior, same side of the transversal, both interior angles. Angles 6 and 11.
Exterior.
Alternate exterior, so I would certainly agree 6 and 11 do appear to be exteriors, but let me ask you this question. What is the transversal that is tied to both of those angles? Well, let's look at it. 11 is at the intersection of A and D. 6 is the intersection of B and C. I don't know about you guys, but I don't think they have anything in common, do they? So this one we would say none. There's no relationship there. They are not tied to the same transversal. So there's nothing we can say about the relationship. What about 4 and 13?
Alternate exterior.
I had alternate exterior, consecutive interior, 4 and 13. They certainly feel like interiors. But then I look at it and I think, what transversal are they both tied to?
None.
None. They are, so angle 4 is attached to lines A and C, whereas 13 is attached to B and D. So again, watch out, there's some sneaky ones in there. Lastly, angles 4 and 9. This one, they are actually tied to transversal A.
Is it
Or-
alternate interior?
I heard alternate. I think people-
Alternate exterior.
alternate exterior, 4 and 9. Careful though, if we're saying A is our transversal, then it's crossing C and D. If it helps, oh, I don't know if I can zoom in that far. 4 and 9 are between the other two lines, so it'd be alternate interior. So far, all we've been doing is naming things. We haven't talked about any measurements, anything equaling anything else, and there's a reason for that. So far, we've just talked about the relationships. And this was when a transversal was just crossing any two ordinary lines, no special, unique things going on. And that's then the most we can do in those situations, is just name them. When we go to the second page, however, we're now going to consider not just a transversal crossing any two lines. We're going to talk about when a transversal crosses a set of parallel lines. Parallel lines are very unique. We've talked in algebra before. Parallel lines go the exact same direction because they have the exact same slope. Here, they actually tell us a lot about the angles created when a transversal then comes in and intersects them. So it says, if two parallel lines are cut by a transversal, then the following statements can be believed to be true. These are facts that I'm giving you. The important thing is, though, recognizing the relationship then. So each pair of corresponding angles is congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. I'm going to jump down here real quick. Recall from, it says unit 1, this recall from last week. Vertical angles, which are angles that share the same vertex and go exactly the opposite direction, are congruent. And then just to spice it up a little bit, change my highlighting color. Almost everything's congruent except for consecutive interior angles are supplementary, which means what? Is that 180 or 90?
90,
Oh, almost.
sorry, 180.
180. And linear pairs, meaning that together they form a line, are also supplementary. So again, these are facts that we are going to use, assume to be true, and use them to find missing bits of information. Now, for our purposes, we're going to just do example 1 together because 1 and 2 are very, very similar to each other. So we're not just doing repetitive action. So in theory, if that were true, if I had a pair of parallel lines intersected by a transversal and all I knew was one of those angle measurements, I have enough information to find all the remaining angle measurements tied to that one transversal. So in our first example here, we are going to find each of these missing angle measures. We've been given the measure of angle 1 here at the top is 65 degrees. And we're going to find all the missing ones and explain our reasoning. So technically we could go in order, we could jump around. I'm just going to go in order so it's easier to kind of correspond our notes together. So I'm going to start with, if we know angle 1 is 65 degrees, how can we find angle 2? So they are supplementary. Do you know why they're supplementary? There's a name for them. They share the same vertex and side. And they form a line when they're attached. They are congruent, but they're congruent because they are a linear pair. So this line right here is formed by angles 1 and angles 2. So angles 1 and 2 are supplementary. We know angle 1 to be 65. If you take that out of the 180, what's left? $115. So I'm going to write down in the note next to it that it is a linear pair to angle 1. Linear pair, again, up above tells me that linear pairs are in fact supplementary. Angle 3 from there, couple options. So now that we have a little bit more information, there's probably 2 good ways to define this one. I'm curious to hear what you guys come up with.
Subtract 115 from 180.
Okay, so you could subtract 115 from 180. I'm guessing then you're telling me that angles 2 and 3 are also a linear pair, meaning they're supplementary. That's good. I happen to know very quickly, though, what they are.
I would say it's 65 degrees because they're vertical angles.
They could all, what are vertical angles? Angle 3 and
1.
angles 3 and 1 could also be defined as vertical angles. So whichever those 2 processes you want to use, subtracting 115 from 180, because 2 and 3 are linear pairs, or saying 1 and 3 are vertical, you're still going to get the same result of 65 degrees. So I'm going to leave the reasoning up to you, whichever one feels right, or if you want to jot your notes, if you want to jot down both, I'm going to go with the one that's always looking for vertical angles. I'm going to say that it's a vertical angle. We'll say vertical to angle 1. What about angle 4? I heard 115. What's your reason? There's a couple ways you could just defend that answer.
Okay. Where are we at? 4?
Angle 4. So I'll write the 115 because I fully agree with that.
Basically, it's the same. It's basically almost flipped. I looked at this whole thing. I don't know how to explain it.
That's fine.
Flipped from the bottom, so I don't know.
So you're saying for the same reason of what we did with 1 and 2, kind of the same relationship of 4 and 3?
Correct.
That's one way to look at it. In fact, we have lots of options here. 1 and 4 are a linear pair. 4 and 3 are a linear pair. which means you can subtract 1 or 3, both of which are measured 65 degrees. You can subtract that from 180. There's actually a third option, and that's when you consider angles 2 and 4, because they would be considered vertical. So I can't tell you which one is best because they're all equally good. It just depends on how your eyes see them. So if you can defend why you answer what you answer, that's the main goal there. I'm gonna say vertical again. This time to angle 2. That is not the only explanation. Okay, so we've kind of knocked out the little cluster there at the top. We're jumping down to the other little cluster, starting with angle 5. We've got a couple options now. What would be the measure of angle 5? Okay, I would agree with that. I'm curious to hear the reasoning. What other angle were you looking at that made you say 65? Angle 1, okay. So how are angles 1 and 5 related? They're not vertical because they have to be attached. They have to share.
Linear.
Not quite. They're still too far apart to be linear. 1 and 5, they are on the same side of the transversal, opening in the same general direction.
Corresponding.
They are corresponding. So corresponding with angle 1. That's one way you could have done it. Did anyone think of it another way? If not, that's okay. I usually go to corresponding angles as well. But if you were looking at this, technically 4 and 5 are consecutive interior. And if you look up above, consecutive interior angles are always supplementary, which means if we took angle 4 measure, 115, and subtracted it from 180, we would get angle 5, which is still 65 degrees. But the more angles we find, the more ways we can defend our answer. There's actually a third one. Angles 5 and angles 3 are alternate interior angles. Alternate interior angles are always congruent. So angles 3 and 5 should be the same. So that 3, very quickly, ways to defend why we get 65 degrees. What about angle 6? 115. Hopefully you're not just assuming this pattern continues to alternate, even though it does. That's a coincidence based off of how we're labeling them. Angle 6, just to spice things up a little bit, I'm going to say angle 6 is an alternate interior with angle 4. Alternate interior angles are always congruent, so 4 and 6 should have the same measure. What about 7? $65. Again, there's lots of ways to defend it, but for the sake of variety, I'm going to say that angle 7 is an alternate exterior with angle 1. Alternate exterior angles are always congruent. Then last but not least, angle 8, 115, because we've hopefully noticed the pattern so far. There's only 2 values being tossed around this whole time. Couple options there. I'm going to say, just because it's been a while since I've used it, I'm going to say it's a linear pair to angle 7. Linear pair, of course, are always supplementary, which means if I take angle 7's measurement of 65 degrees, subtract it from 180, I'll get the 115 we just wrote. Any questions on those? Again, the reasoning behind it may vary. The further in you get, the more options you have to explain your answer. But the answers themselves, the actual measurements, should remain the same. like I said, I'm gonna skip over number 2. It's more or less the same thing. A lot of the same 2 values being tossed around for basically the same reasons. I want to jump ahead to, let's start with number 3. Number 3 is a little bit spicier. This time we actually have 3 parallel lines, all 3 of them parallel to each other, with a transversal going through each of them. Now, some of you might be thinking, oh my gosh, that's too much to look at. Well, it requires a little bit of imagination of, I can't really do it very well from here, ignoring one line at a time, ignoring one of those parallel lines when you're trying to relate them together. But what our goal is here is we want to work our way through these angles and find their measurements. We aren't going to write the reasoning, but we will say them just so we make sure we're on the right track and go from there. So this one's throwing us off a little bit. Instead of giving us angle 1, it is giving us the measure of angle 5, which I'm actually highlighting there, is snuggled there right inside that middle parallel line. And maybe we have enough information to start with 1, maybe we don't. In this case, I don't think we do, because angles 5 and 1 have no relationship. They are alternate, but one is interior, one is exterior, and there's no relationship for that. So I'm actually going to suggest we jump to 2, because 5 and 2 are a linear pair. So what could I find for the angle measure for 2?
You subtract 180 from 82.
So 180 minus 82, which would give you, I believe, 98. Okay. Now, again, this is entirely up to you, but this is something that I like to do to go bang, bang, bang very quickly. I now know that angle 2 and 1 are corresponding, which means congruent. 2 and 3 are corresponding, which means congruent. So very quickly, 1, 2, and 3 should all be 98 degrees because they are all corresponding angles, either one with the other or vice versa. Any combo you want, 1, 2, and 3 are all corresponding angles. Now, just because I'm all about shortcuts most of the time, I'm actually going to jump. So we found 1, 2, and 3. I'm going to go up over here by 1 and jump diagonally over to 10. What's the relationship between 1 and 10?
Interior.
Well, just look at it. So let me zoom in right here. 1 and 10.
Corresponding.
Not quite. They are
Vertical.
vertical because they share the same vertex, and vertical lines are always congruent as well. So whatever angle 1 is, so is angle 10. So 98 degrees over here. But the same thing I did with 1, 2, and 3, angles 10, 11, and 12 are all on the same side of the transversal, all opening in the same general direction, therefore are all corresponding, which means 10, 11, and 12 should all be congruent as well. Again, this is not the only path we could take. We could work around one little cluster and then jump to another and then jump to another, but there's so many possible routes, it's not fathomable to be able to do all of them all together. I guess if we wanted to, if we go back to our original angle 5, do we have any corresponding angles with 5?
4 and 6.
4 and 6 are both corresponding. That means 4, 5, and 6 should all be the same measure, which we are given 5 to be 82 degrees. And then if I were to look there, again, going back to number 5, vertical of 5 would be 8. So 8 would also be 82 degrees, but what are some corresponding angles to 8?
Nine.
9, and I would also throw in 7. So again, there's lots of ways we could defend why each of those measures are the same. but more or less, we should be able to work our way through it. We're doing on time. 1:30. Oof. I'm going to jump to number 5. Let's go to example 5. Example 5, we were given two measurements. Measure of angle 7 is 38 degrees, which is snuggled in down here in the bottom left. Careful, notice we have one set of parallel lines. They are denoted with this little double arrow. So these lines are considered parallel. And through those parallel lines, we have two different transversals. Let's make sure we don't accidentally mix and match here. So we are going to have some different measurements going on rather than just the same two. Measure of angle 10, we've been told, is 102 degrees. And we're going to work our way through it from there. So I'm going to do an easy one. Angles 5 and 7 are vertical angles. So 5 and 7 should be the same measure, 38 degrees. I'm actually going to keep running with angle 7. I'm going to notice that angles 7 and 15 are corresponding. So they should also be 38 degrees.
Wow.
13. So whether you want to say 13 is corresponding to 5, which we already have, or we could say 13 and 15 are vertical. 13 then should also be 38 degrees. Okay. I'm going to jump back to angle 7 and scoot over to angle 8. 7 and 8 would be defined as a linear pair, which means they are supplementary, which means they should add up to 180. So if I took 180 minus 38, what would I get?
142.
142. So angle 8 is 142 degrees. But could we then say angles 8 and 6 are vertical? They share the same vertex, opening opposite directions. So angle 6 should also be 142. And then again, notice I'm really kind of hanging on to this bottom transversal here. I'm knocking those all out all at once. What if I said then angle 6 and 14 are corresponding? That would mean 14 is also 142. And 14 and 16 are vertical. So there's another 142. So as I mentioned once already, I just knocked out all the angles down here with this bottom transversal. What hopefully you noticed as well is I did not say anything about the measurements of 5 through 8 and compare them with 1 through 4. And here's the reason why. If I were to zoom in right now, oof, I don't know if I can do this very well. And I asked you for just a moment to imagine, check that out, that relationship there. Is that a transversal intersecting parallel lines? It is not. It is a transversal. Sure. It is a transversal, but it is not intersecting parallel lines. Therefore, there is, other than naming them as corresponding or alternate interior or alternate exterior, we cannot say that they are congruent or supplementary or anything like that. That only works when the transversal is going through parallel lines. So that is a distractor there, because what we want to look at then is the second transversal up here at the top with respect to these parallel lines. So the good news is I can kind of ignore these angles now. I've really kind of taken care of that cluster. I can go to work here on the top. And I don't want to carry any of these numbers over because these numbers share no relationship to this grouping here at the top. So I'm going to work my way around with angle 10. So we were told angle 10 was 102 degrees. I'm going to go the easy route real quick. Vertical with angle 10 is angle 12. So that's another 102 degrees. "12 and 4 are corresponding. There's another 102 degrees. 4 and 2 are vertical, or I could have said 2 and 10 are corresponding. So there's another 102 degrees. All that's left now is to figure out that missing value, which I would go back to angle 10 and say, you know, maybe 9 and 10, linear pair, therefore add up to 180 because they're supplementary. So if I take that 102 out of 180, what do I get?
78.
78. So angle 9 is 78 degrees. And by that similar process, I can work around with my verticals and my correspondings. I should get that all these other remaining angles that I had left should all be 78 degrees as well. Now, like I mentioned, don't get distracted when you have multiple transversals. When you're trying to find angle measures, first identify the parallel lines, because those parallel lines most of the time will not behave as your transversals through that process. Now, if I really wanted to throw you a curveball, I would have two parallel lines intersecting a different pair of parallel lines, in which case then you could work your way all the way through that, because they're all one way or another related, which actually would be a cool preview into like one of our last units when we talk about polygons, quadrilaterals, rectangles, rhombus, trapezoid, things like that. I don't want to spoil too much of that for you here today. I would like to take a quick sneak peek here at example 6, just because again, there is some distracting information here. We were given 3 angle measures, which probably important because of how this image is constructed for us. Measure of angle 2, which is nestled in here, is 41 degrees. Measure of angle 5 is 94 degrees, which is down here. And measure of angle 10 is 109 degrees, which is over here. Now, what I meant by confusing is the fact that my parallel lines are cut off with endpoints. They don't go on forever, which for some people could be awfully distracting. So what I would suggest is maybe extend those out a little bit further. So I can clearly see those parallel lines for where they're going. And then I would also, if you notice, there's kind of this diagonal line going through the middle, which also got capped with endpoints. Just for the sake of saying where one angle goes to another, I'm going to suggest we go ahead and extend that one out as well. We don't have to go too crazy far, but just so we can start to see the relationships here. Because now the confusing bit is that we have technically 1, pair of parallel lines, but 3 different transversals. The most confusing part, though, is these 2 transversals right here exist nicely and independently of each other. What throws us off is the 3rd transversal actually intersects the other 2 transversals, which makes for our measurements to be kind of jumbled. So what I'm going to do is I'm going to suggest we work our way through here, finding what we can, where we can, as we get through here. So the first one, if I was looking at this one, is I would go to my vertical angles or my corresponding angles because I know they are congruent. And as I dig through here, there's not much I can do except for angle 10, again, focusing on my parallel lines here, angle 10 is corresponding with angle 7. So 7 and 10 both will have a measure of 109 degrees. Now from there, I'm going to go with my linear pairs, the ones where I'm looking for where things aren't too jumbled. So I'm going to jump over here to angle 5. 4 and 5 clearly together form a line, therefore are a linear pair, meaning they are supplementary. So if I know 5 is 94 degrees, I take that out of 180. What's that leave me with? 86 degrees for angle 4. Which thankfully, angle 4 and angle 1 are also corresponding. So angle 1 is 86 degrees also. I'm going to jump back over here to my angle 7 that we just found just moments ago. Angle 7, we said was 109 degrees. 6 and 7 are a linear pair. So if I took 109 from 180, we would get 71 degrees. Now, here's where it starts to get weird because 2, 3, 8, and 9 are behaving strangely. They are interior angles that have been cut into 2 pieces. So what a lot of students will want to do is say that angle, for example, angle 6 is corresponding with angle 8 or angle 9. That's not actually true. Angle 6 is actually corresponding with 8 plus 9. So that's where it gets a little bit fuzzy. So I need to come up with a neat way to figure out at least one of those parts. And I actually have something, which if you'll bear with me for just a second, if I hide some of this distracting information, for instance, where am I going to hide it here? If I were to, oop, that was too much. If I were to hide this bit of information here, that's also too much. And this bit of information here. I notice, hopefully, that angles 2 and 9, again, I have the advantage of I can wipe things out very quickly, but then it's an eye training game. Angles 2 and 9 are alternate, because they're on opposite sides of this transversal, interior angles. And alternate interior angles are always congruent as well. So I bring back, oops, I think I redid too much. Yeah. So 2 and 9 are alternate interior, therefore congruent. 2 should equal 9. So 9 is 41 degrees. So in comes then angles 3 and 8, which are the trouble ones because of how they've been cut. So earlier I mentioned that 6 is corresponded with 8 plus 9. Now, do I now know what 9 is? Yes. So I now happen to know, I'm going to sketch in here, that this whole angle, 8 plus 9, equals angle 6, which we said was 71 degrees. We know 9 was how many of those degrees? 41 of them. If you take that 41 away, you should be left with angle 8. Sorry?
Are you taking 71 minus the 41?
71, take away 41. Yes,
30.
should be 30. Angle 8 should be 30 degrees. And then we're going to actually use a similar process over here for angle 3 because angle 5 is corresponding with angles 2 plus 3. But what was angle 5? 94. We know what 2 is. So from that 94, take away the 41. I believe you get 53. So that one was sneaky because some of the relationships looked more like the ones we know, but were deceiving because they were cut by that weird diagonal transversal that cut everything. All right. So I know we skipped over a few. If you're curious in the future, you want to, if you work some of them out and you want to check, just let me know. But this gives us a decent variety so far. The last page, again, we're not going to do every single one of these, but there are a handful where we'll solve them all the way through. But I'm more interested in setting up the equation. Is it safe for me to assume that if given an equation, you could solve it? Which would be like week 1 of Algebra 1. If not, again, at any point, if you're like, man, I really just don't remember how to solve equations, come see me. I also happen to be the Algebra 1 teacher. So I can work you through that process or pull up some of my notes, give you some of my clues, things like that. So the new part today is setting up the equation. Solving it, that's Algebra 1. So we are given directions here, which is good because in the directions, it gives us this notation. If, oops, that's the wrong tool. If lines L and M are parallel, find the value of each missing variable. So it verbally, well, textually gave us a statement to tell us that in every one of these examples, L and M can now be assumed to be parallel. Now, if you're a visual human being like me, I sometimes even go one extra step and put that little double arrowhead on there so that I know which of my 2 lines are considered parallel. Again, not required, but something that could be done. The reason for that is because then we now know that if those are the parallel lines, this third line must therefore be my transversal. And then I can go into, okay, what kind of pair of angles are these? And based off of that naming convention, what is the relationship? Are they congruent or are they supplementary? So in this case here, I'm going to actually write the relationship first underneath the diagram, and then we're going to write our equation. So we're searching for x in this case, and we've given an expression for this angle and a measurement for this angle. How are these 2 angles related to one another? Same side of the transversal, opening in the same general direction.
Corresponding.
They are corresponding angles. So underneath, I'm going to write a little note here that these are corresponding angles. And if I go to the previous page, we said that corresponding angles are always congruent, which means then that 5x minus 2 would have to equal 58 degrees. That's the geometry of it, setting up the relationship. Everything else from this point forward is just algebra, solving for that variable. So adding 2 to both sides, I get 5x equals 60. Divide both sides by 5. I believe I get x equals 12. Now make sure you read that you're solving for the right piece. And this one, the instructions just said solve for the missing variable. So we found it in that case. So I'm not going to solve very many of these, but I'm going to show you how to set up the equation, and I can tag in the answer at the bottom if you're curious of your equation solving skills. But if I move on to number 2, we're searching for x again. What's the relationship between the two angles for which we have some sort of information? L and M again are the parallel lines, therefore the third line is the transversal. The information we have appears to be on opposite sides of the transversal, or alternate sides, I should say. And I think I heard it. They are alternate exterior angles. Now, here's the good news. It's almost a coin flip as to whether you set these up correctly. Because on the previous page, we only said they could be one of two things if they are in fact related to one another. They're either congruent, meaning set them equal to each other, or they're supplementary, meaning add them together and they should equal 180. So it's not too many options to go wrong here, so long as you've kind of been along with us for the ride. So alternate exterior angles are congruent. So our equation could be 16x plus 22 equals 134. If you were to solve that one all the way through, you should get x equals 7. I'm actually going to skip number 3. I'm going to jump down to number 4 because number 4 is a little bit different. Number 4, they've shifted the picture on us. The L and M, our parallel lines, are now going vertically. Transversal is kind of coming in at a diagonal. What's the relationship we've been given here? How would you define those two angles? Consecutive interior. I don't know where I'm going to squeeze that here. Kind of real small here at the bottom. Consecutive interior angles. And this is one of the different ones. Consecutive interior angles are supplementary, meaning when you add them together, they should equal 180. So you do literally that. We'll take the 9x plus 2, which is one angle, plus the second angle, which is 133, and that should equal 180, making them supplementary. This one I will solve real quick, just because it's a little bit different. Because instead of being just a two-step equation, this one also has like terms in it, which I would recommend combine those before you go moving things from side to side. Save you a few steps later. The 2 and the 133 will give me 135. And then to solve it, I'm going to subtract 135 from both sides. Oops. Too fast for me, Misty. What was the 180 minus 135? 45. So 9x equals 45. Divide both sides by 9. You will get the x equals 5. So again, like I said, one of two options. They're either going to be congruent or they're going to be supplementary. That's going to influence what type of equation you set up based off of the information. I am going to jump down very, very, very quickly down to number 9. Number 9, what do you notice right off the bat? What's different about this one? There's 3, not equations, expressions. I'll nitpick a little bit, but look in those expressions. Anything else different about these? There's a y. Okay, so we have two variables defined now. And here's the thing, and you might recall this from algebra. In order to find two variables, you're usually going to end up needing at least two equations. Now, when I go to relate things together, would it make sense to relate these two expressions together right now, knowing neither of those two variables? No, because I would get one equation with two variables in it, and that wouldn't get me any closer. So instead, I would rather try to find one variable first, because that'll probably help me find the remaining one. So I'm going to look, and I notice that I have two expressions that use x, so I'm going to work with those first. So 8x minus 31 and the 6x plus 3, those are alternate interior, meaning that they are congruent. So we'll say alternate interior. Tells me that 8x minus 31 equals 6x plus 3. Solve that real quick. Get the variable to one side first. Subtract 6x from both sides. I get 2x minus 31 equals 3. Add 31 to both sides. I get 2x equals 34. Divide both sides by 2. What do I get? X equals 17. Now, I still need the y. But what I could do then is I could take, oops, nope, not there. I could take this x and drop it in here and figure out the measure of that angle. What, so 6 times 17. What is 6 times 17? Sorry?
102.
102 plus 3 should be 105. Because then when I come over here and I go to try to find y, 6x plus 3 and 5y plus 35 are consecutive interior angles. Can't spell today, apologize. Which means the 105 that we just calculated plus the missing one, the 5y plus 35 should equal 180 degrees. Now, because of time, that's why I'm going to leave that one there. If you want to go through the process of solving it, be my guest. I will tell you if you want to check later, y is going to end up equaling 8. If my work here is correct. If it's not, bonus points to the person that proves me wrong, because I may have made a mistake. So that is where we're going to conclude that before we take a look at the assignment, which is more or less the same thing, just one sheet of paper again.